Okay, great question. What is forbidden on the ISS? Not a rhetorical question. What is not allowed to bring on the ISS? What do you say? Fire? Possibly, I guess so. Fire? What else? It's not the answer I'm looking for. Alcohol. Who said that? Alcohol is right. You can't bring alcohol, you can't bring glass bottles. But this next group did. They managed to age 12 bottles of wine on the ISS. You're going to hear a little bit more about that. One has built 9 startups. The other one has 6 patents. I'll let you decide who did what. Please welcome up the wonderful Nicolas and Karine.
Good afternoon. Space Cargo Limited was born here in Luxembourg 7 years ago with the strong belief that the next revolution, industrial revolution on Earth will happen in space.
A defining industrial revolution that would capture the immense and untapped potential of space for a fragile Earth in need of solutions.
So we started by doing a first mission, which involved sending wine into the ISS. We actually sent a number of other items, vine plants, wine cells. We flew with SpaceX, with Blue Origin, multiple flights on the ISS, 10 months, 14 months. And across the past 6 years, we learned a lot about how achievable the industrial revolution that we envisioned would happen. And we realized there was many challenges, many flaws. And it's because we did this first commercial mission, truly commercial mission, generating revenue, and from beginning to end, that today we're announcing an exciting new project. So, I'm Nicolas Gaume, co-founder and CEO of Space Cargo Limited.
I am Karine Courtin, board member and a committed investor to the company.
Karine, as an entrepreneur, has started his life with academics. She has a PhD in microelectronics. She worked at Safran Technology and Defense on defense projects before pivoting in the cosmetic industry in tech and innovation.
Nicolas, you are the co-founder of Space Cargo and you grew up with your co-founder, Emmanuel. You built 7 startups with a lot of successes and 1 IPO. Tough moments sometimes, but 5 successful exits. Briefly, you were very interested in general on emerging markets and frontier technologies.
And you, Karine, with your investment into Space Cargo, always pushed us to go to innovation, to disruptive technology. In fact, when you look at the past 2 decades of the ISS, you realize there was an amazing amount of research done. Basically, every single astronaut is spending his, her, or their day doing research on a variety of topics. These research rarely become a product, rarely become an actual mechanism, even though we feel there's a ton of opportunity. So let us talk about microgravity a bit and its immense potential back on Earth applications.
So many opportunities with microgravities. With microgravities, conditions for observation, fabrication, and measurements are perfect. If we take the example of pure materials, we have no oxygen, so no oxidation, no impurities to contaminate crystal growth or deposition, so this is a huge advantage. Another example, optical lenses?
Yes, alloys. When you blend different materials as an alloy, the heavier material is going to go down because of gravity, the lighter material is going to go up. So you do not have a homogeneous material. You have something that is not as effective, as completely blended as it would be if done with no gravity. Other examples in agriculture. What you're seeing here actually are plants. These are actually the 4,000 vine plants. We come from the vine plants we sent to the ISS. They're growing into a lab in Bordeaux in our subsidiary Space Biology Unlimited. They are actually the lab of INRAE, our research partner, and CNES. We actually growing these plants. We were exposed to space for 10 months and transformed. We actually created a new variety of plants organically. Let me tell you a bit about this. I think it's interesting. We exposed these plants freshly cut straight into the ISS. It was a bit of a logistical nightmare to achieve that, but when exposed at a very young age, these living organisms had to face the highest stress of a lifetime at absence of gravity. In fact, since 4.5 billion years of life on Earth, the only parameter of life that has never changed, or the main parameters, is gravity. All the others, temperature, pressure, humidity, have changed drastically. There were years of darkness that killed the dinosaurs. There were ice age with low temperature, warmer tropical ages. So as the species died and evolved and changed, the only constant was gravity. It became the backbone of life. All of you here are structured around gravity. You have a heart that is a pump pushing your blood from the bottom of your body to your brain. It's optimized with valves that are actually working most effectively when you stand. And down to your cellular level, gravity is what defines you. So when we put these plants in this environment, they completely freaked out and evolved faster than anything else. Idea is that we generate a new variety. We have proven that genetically. It's no longer the same plant than the one we had when we launched. And we brought them back with the idea that these plants will be more resilient, more resistant to lesser stressors, such as the one related to climate change. So we expose these plants to higher temperature, stress, water stress, or a lack of water thereof, and disease, specifically fungi, and one disease called mildew, which is a very unfortunate disease that is growing with climate change, that is extremely challenging to one in any agriculture. And among the species we have collected, a large number of them became extremely more effective in defending against these attacks. So we now have organic plants that are more resilient to climate change. We still have a year of research. We actually have vine plants that are very effective. We haven't tested the quality of the wine, the grapes, and the ability to make good wine out of it. We're confident it will be, but we need to do this next year. And we're planning to bring these vines to the market, selling to Château Latour, Château Petrus, Château Cheval Blanc, Burgundy, Italian, South African, Napa Valley wine. It's planned to generate for Space Cargo up to 10 million euros of licensing fee per year. And it is arguably, again, a real opportunity that we see thanks to gravity. Let's put a little bit of time on this, but this is a very exciting project we've been working on for the past years.
Yeah, we can extend this to other plants.
Absolutely, all other plants. Another application plan.
Two last applications to illustrate microgravity. Of course, there is no capillary forces and no surface tension, so we can build out as well spherical lenses with very big accuracy as you feel like. And a last example for life science as well. If we think about the 3D printing of living tissues, with the gravity, these tissues tends to collapse, and what we need for the heart organ, for example, is space into the tissue. We need to breathe and to have these chambers, and with microgravity, so then we can build this tissue as it should be for the human body. That was
exciting. So we have a team of 15 researchers. We've been working on the topic of in-space manufacturing for this decade. We really are excited about the application to agriculture, life science, new materials. And we believe it's really right there, waiting to be seized.
So with all that, Nicolas, is in-space manufacturing still the underdog of space?
It is definitely the underdog of space. It's actually something that didn't really materialize as a business. Actually, we've been talking about industrial and manufacturing space for 3 decades. 2 things blocked. Obviously, access to space, like many other topics, being able to launch payloads into space at a low cost. And as you all know in this audience, it's changing. $1.250 billion to actually launch the space shuttle, $250 million to launch Dragon. And now the price is dropping sharply thanks to amazing startup, among them exciting ones in Europe, in Germany, in France, in Spain, all over Europe. So that's actually a defining factor that makes a difference. The second topic, and again, as we experienced the first commercial end-to-end space mission, multiple flights to the ISS, is also the reliability of the platform, the effectiveness of the vehicle that is going to make manufacturing happen. And ISS, as all the other space stations, have a really exciting prospect to continue research. But when it comes to production at scale, there's a ton of limits. One of them is the presence of humans, which really put a lot of constraints and limits. So we started on this journey now 2 years ago with our partner Thales Alenia to design the ultimate factory, which we're excited to announce here today. If you want to roll the video. Somewhere. proud to announce here in Luxembourg, our headquarter home, to talk about this. If you can put the slides back, please, to show you REV1 and tell you more about it. REV1 has been designed with our experience, 7 years of hard work. I should say more because we're fortunate to have a wonderful technical engineering team coming from Airbus, different from space. I've been working on this topic of in-space manufacturing for nearly 2 decades. Key characteristics, I won't go too much into the details. You should reach out afterwards if you would like to have them, but no humans, as you have heard. Completely dedicated to in-space manufacturing. We do not believe in multi-purpose vehicle. We are extremely focused on in-space testing and manufacturing. We also have versatile launcher capacity. We can fly with any rockets. That's coming in the 2-ton plus capacity. We're Europeans, German engineering leadership team, home in Luxembourg, research team in Bordeaux, and now Torino, as we have decided to be as a fabless organization, really structure our partnership with Thales, which will tell you a little more. For those of you who know the European Space Agency programs, you would have recognized the heritage of REV1. We're actually leveraging the success and the proven record of ISV, a program that flew now close to 8 years ago, and the successor, Space Rider. We're really leveraging the technology that matters, like re-entry shield and other things. We changed a lot of things, though, to optimize process, to make sure we would serve the need of our in-space manufacturing customers and partners, and certainly untap and unleash this high potential. We also made sure, and that's obviously a key function, that we will have the right price to really get to accessible for industrial companies of the multiple verticals we're going after. Thales Alenia Space, a great partner of us in this process.
So REV1 will be built by Thales Alenia Space, and we are very impressed and inspired by their high level of expertise, especially in pressurized vehicles. And we built a link, very unique link with Thales Alenia as they participate to our mission to the ISS 2 years ago, and they were working on it 3 years before. And this link is very, very important for us because it's kind of wedding in between a startup and a historical key player of space industry. So we are very happy about this. Definitely Thales will bring leadership and expertise from the project IXV and the Space Rider. And our common vision will be to build REV1 to be cost-effective, robust, and of course,
ready to market.
Ready to market and to unleash this in space
I would like to
manufacturing.
add is that we also obviously have to be very innovative. We're very fortunate to have a wonderful VC working along with us, Emmanuel Chopard, my co-founder, myself, Euraseo, one of the leading VC firms, Expansion, the fund from Charles Becbédé, a well-known French entrepreneur launching the Space Fund. Thales Corporate Venture is also part of the journey, but more importantly than the fund, it's really the way we structure our partnership, the way we're also going to change the way you usually typically do and deal with capital-intensive projects such as those. So stay tuned next year for more announcement, both on the delivery of the vehicle as much as the way we continue to innovate in our project.
Launch
Launch date 2025.
Yes.
So come and fly with us. Thank you so much.